Hello guys, today we are going to be doing this question. I would recommend you guys to try it first because it is quite easy if you know how to deal with graphs and you know a relation between force and potential energy. So the relation that we need is this one. As work done is the negative of change of potential energy of a conservative force only, because potential energy does not exist for non-conservative force. So this is for large quantities, like large quantity of work is negative change of potential, like in a spring, if a spring does some work, there will be loss from its potential energy. It is saying that only whatever it is losing, it is doing work, and that is why this minus sign is there. If it is losing from potential, then it is doing work in actual life. So then this is what we would say a difference, equation for small quantities. Now for small quantity, work can be written as f dx, because a small displacement, so f dot dx, and if they are in the same direction, then f dx equals to minus du, small change in potential energy. From this equation we can make, or we can have a relation, so that we can have the equations of u, because if we integrate it, then we can get a relation between u and f. So that is exactly what we want to do, because we have been given the graphs of u and not f, but we have been given the equation of f. So from this we get that integration of f dx minus equals to integration of du, which is going to be u, and this integration we can do it like dx. Okay, that was minus, so this will become plus, and then minus integration of bx square dx, and finally we will get u equals to x square by 2 minus, because this plus minus, bx cube by 3. Now we need just a tiny bit of concept about equilibrium, then we can easily delete these two options from our answer, because I'm gonna tell you. Suppose this is a u versus x graph. Well, this is not that bad still. Now wherever the tangent of u, this graph, this is u versus x graph, if you see it properly, then du by dx equals to minus f from this only. So what does this represent? A tangent. That means the tangent at any point is equals to minus of the force. That means negative of slope at any point is the force acting on the body. But we don't want all that complicated things. We want only if the slope is 0, that is over here, here, and suppose it went like this straight, then the slope would be 0 at every place. Then at this place force would be 0, at this place force would be 0, and similarly at this whole place force will be 0. So for force to be 0, there has to be a like this or like this. The tangent has to be 0. Now if you notice that u is totally dependent on x, so if we put x equals to 0, u has to be 0. And not only that, if you see at if we put x equals to 0, f is coming 0. That means at 0 there has to be a tangent like this, a tangent parallel to x. As you can see, at 0 this has a tangent parallel to x-axis, and this also has a tangent parallel to x-axis. If I have drawn it a bit badly, then I'm sorry. but this does not even has a x equals to 0, and this whatever it has, it does not have that curve. That is, its tangent will be something like this, having a negative slope. So these two are already out of the question. Now distinguishing between these two, if you see, this has a point where u has become 0, right? But this does not have it. So you have to check that can u become 0. So for that, okay, another condition of in the question was given, I forgot to mention this. Okay, now if you check it, suppose you make u equals to 0. So x square minus x square by 2 minus bx cube by 3 equals to u equals to 0. Suppose I had made it just to see if there is any possible value of x at when u equals to 0. So x square, two possible results, either x equals to 0 or a by 2 equals to bx by 3, x equals to 3a by 2b. And as we are given x is greater than 0, greater than equals to 0, a is positive, b is positive, that means this root exists. That means this is a point that exists, and that means a real graph should have cut at x-axis, which this graph did not. So this is also wrong. This is the right answer only. Thank you for watching.